The one plant essential nutrient I talk about more than any other nutrient is nitrogen. And in my soil fertility class, the students have to memorize the nitrogen cycle. Thought I'd take a little bit of time today to work through some of the components, so when you see me on sunup talking about the nitrogen cycle, you have a better idea of what we're going through. So when the students are in class working on memorizing this nitrogen cycle, we go through a couple steps. One thing that we always start off with is the central component. So the central component is what everything operates around, and that for nitrogen is organic matter. We say organic matter is a central component because everything operates around it. In organic matter, there's a lot of nitrogen. So nitrogen coming out of organic matter can really contribute to the system, and nitrogen also goes into organic matter, removing it from the plant availability of the system. So also in the nitrogen cycle, so we have the one central component, we have three primary nitrogen sinks. So one of the nitrogen sinks is the nitrate pool, so NO3. This is the plant available pool that's sitting there where we have a big reserve of nitrogen. Up here up top, we have atmosphere. The atmosphere is a huge pool of nitrogen. It contains a significant amount of diatomic nitrogen, and so it is the largest pool that we have. The third pool, so remember one central component, three sinks, is the microbial and plant. So microbes and plants, living microbes and living plants contain a significant amount of nitrogen in them. So we have our one central component, three nitrogen sinks. Then, in addition to that, we also have our loss pathways. So we go one central component, three sinks, and now we have four loss pathways that all these students learn about. So we go from nitrate, with nitrate we have the leaching pathway. With leaching, that is water moving down and carrying nitrate with it. From nitrate, we have a couple other pathways. One here, we bring it up this way, and this one is our denitrification. Denitrification is when when nitrate's sitting there and the soil becomes anaerobic, or basically it has water. It is sitting in water, so there's a lack of oxygen. The oxygen is pulled from nitrate and it turns into nitrogen gas. And so we have a loss pathway going up this way of denitrification. We also have another pathway that's not just a loss, but we have nitrogen coming up here when we draw this out, and nitrogen from nitrate turns into ammonium. The ammonium is taken up into the plant. So we have the ammonium into the plant as a form of amino acids, but we have plant loss as one of our pathways. This is one of those loss pathways that a lot of people don't think about, because the ammonia accumulating in a plant when the conditions are hot and dry, that NH4 actually becomes toxic when the plant is lacking water. So the plant is drawing it down and it becomes ammonia. So the plants can gas off ammonia. In a hot, dry season at around flag leaf for winter wheat, if it gets really hot and really dry, we can lose an upwards of 20 to 30 pounds of ammonia gas through the leaf alone. So now we have 1, 2, 3 of our loss pathways. Over here we have another pathway that is ammonia loss. So this is actually NH4 or NH3 being volatilized. So ammonia volatilization. And that's our fourth pathway. To get there though, it's coming off of, we have NH4 setting right here in the system, and in a hot, dry environment, NH4, when it's hot, when it's dry, that ammonia actually has a H stripped off of it and turned to NH3 gas. Now you ask, we got ammonia sitting out over there. How do we get ammonia over there? So in this part of the nitrogen cycle, we have organic matter, have nitrogen as organic nitrogen, which is our NH2. It's what we look at as organic nitrogen. It's converted through a process called mineralization into NH4. Now when it's in the NH4 form, we can have it as going up in the gas or being held onto the soil, CEC. That is the exchange site. So I say ammonium, NH4, is a immobile nutrient because it's positive. It's holding on to the negative cation exchange charge. So we have this organic matter going over there. Organic matter is also going into the nitrate pool. So through mineralization, we have nitrogen going nitrate, and we also have nitrate being converted back to organic matter. Now, our plants and microbes are taking up nitrate into them systems. They're also taking up ammonium. So they're absorbing, plants and microbes are eating ammonium or taking it up. And the plant and microbes, when they die, guess what? They go into organic matter. So now you're starting seeing all this stuff start circle together. On this side, we still have to get this NH4 has one more loop that's going this way. So NH4 coming down, we have the conversion, we call it nitrification. That's when we turn NH4, that immobile nutrient, into nitrate, and we use bacteria. Bacteria is used to do it, so bacteria is breaking down NH4 and turning NO3 through nitrification. Those bacteria, Nitrosomus and Nitrobacter, convert. They strip the hydrogen off and basically add oxygen to it, turning it into nitrate. So we have our central component, our three pools. So we have our nitrate, microbial plant, and atmosphere, which we have our volatilization going up here. We also have the denitrification going in here, adding more nitrogen to the atmosphere. And of course, so we have everything in here. The one thing we have left is additions. So this additions to the system, not just due to the microbial plants dying, we have lightning and rainfall is contributing to the system. Every time it rains or every time it has lightning, we add nitrogen to the system. We also have the industrial fixation through different manufacturing processes. We create nitrogen and have that in the system. Then, of course, we have fertilization. So farmers applying fertilizer to the soil adds nitrogen to the system. So this is kind of a brief rundown of the nitrogen cycle. And the importance to producers are, if you understand what is happening to nitrogen, either because of rainfall, because of cold weather, because of the addition or removal of organic matter, you have a better understanding of what's going on in the field, like what we saw this fall when we had so much rainfall occurring in much of our wheat ground. To see the full nitrogen cycle that my students have to reproduce in class on a blank sheet of paper, check out the SunUp website at www.sunup.okstate.edu.